This video will build upon my previous one on increase or decrease by a percentage. If you haven't watched that video, I'd highly recommend you watch it first. There'll be a link in this video's description. The first thing we need to understand in this topic is the meaning of the word interest. Interest simply means the cost of borrowing money. For example, if you go up to a bank and ask them for a loan, then you are borrowing money. The bank may lend you this money, and you can do what you wish with this money, but over time you will need to pay this money back to the bank. The bank will not just do this for free though, they will charge you for this service, so you'll have to pay an extra amount of money back to the bank, known as the interest. In this example then, you had the original loan, the amount of money you borrowed, and then the interest was the extra amount you had to pay back to the bank. So we can now see why the interest is the cost of borrowing money. You can also receive interest though. If you take your money and place it into a bank, the bank will pay you some interest on top of this. You're effectively loaning the money to the bank, even though you can withdraw it at any point. The longer you leave the money in there, the more interest you'll receive. This is the type of example we'll look at in this video. There are two types of interest you need to be aware of, known as simple interest and compound interest. We're going to look at simple interest first. Let's imagine that you're going to place £6,000 into a bank, you're going to leave it there for 3 years, and the bank says that it's at 5% interest. This 5% here is the rate of interest. It will help us work out how much interest you're going to receive each year, and in this case it's 5%. So for this example, with simple interest, we would begin by working out 5% of the amount of money you invested in the bank, so £6,000. To do 5% of £6,000, we do 0.05 multiplied by 6,000. This will give you 300. This means that each year you leave your money in the bank, you'll receive £300 in interest. But of course you're going to leave the money in the bank for 3 years. So you started with £6,000, which we could call the initial amount, and after year 1 you will have gained £300, so you'll have 6,300. After year 2 you will have gained another £300, so it's now 6,600, and after year 3 another 300, so 6,900. Since we're adding £300 here 3 times, we could simply multiply 300 by the number of years, which is 3, which will give you 900, and just add £900 in one go. So at the end of the 3 years you'll have £6,900. Let's see if we can apply this to a different example. In this one, it's £8,000, it's 4 years, and the rate of interest is 3%. So let's start by working out 3% of 8,000 by doing 0.03 multiplied by 8,000. This gives you £240. This means that each year you're going to receive £240 in interest. But you're going to receive this each of those 4 years, so we multiply this 240 by 4. This will give you £960. So in total, you'll receive £960 in interest. So to find out how much is in the bank at the end of those 4 years, we just add on the interest. So we started with £8,000, and we gained £960 in interest, so we now have £8,960. Here are 2 practice questions for you to try on simple interest. Pause the video and give them a go. In the first one, we have a rate of interest of 4%. And the amount invested is £500, so we'll start by working out 4% of £500. We do 0.04 multiplied by 500, which gives you £20. This means that each year you'll receive £20 in interest, but this investment is for 6 years, so we must multiply this by 6. So £20 multiplied by 6 is £120. This means that across all 6 years you'll receive £120 in interest, so we just need to add this on. So we started with £500, we gained £120 in interest, and if you add this on, you get £620. In the second example, the rate of interest is 2.5%, and the amount invested is £320, so we need to find 2.5% of £320. We do that by doing 0.025 multiplied by 320. This gives you £8. So each year you'll receive £8 in interest. This investment is for 3 years, so we'll multiply that £8 by 3, which will give you £24 in interest. We just add this on, so £320 plus the £24, which will give you £344. So that was how simple interest works. This is the original example we did, but let's repeat this but change it to compound interest, which is slightly different. Obviously in this example, we're starting with the same initial amount of £6,000. And actually for year 1, it will be the same calculation as it was for simple interest. We just work out 5% of this value here, so 0.05 multiplied by £6,000, which was £300. We then add on this £300, which means after 1 year we will have £6,300. But here's where things change. For compound interest, the amount of interest that you receive is calculated on how much you have at the end of that year. So for the year 2 calculation, we're going to add on 5% of the amount of money we have at the end of year 1, which is not £6,000 but £6,300. If you do 5% of £6,300, you get £315, not £300. So to calculate how much we have at the end of year 2, we will add on £315 instead. This will take us to £6,615. And then for the next calculation, we'll add on 5% of this number. So we do 5% of £6,615, which is £330.75. So to calculate the amount we have at the end of year 3, we add on £330.75, which will take us to £6,945.75. You'll notice that if we compare this to the simple interest calculation from before, in simple interest, you are adding on £300 each time, so the same amount. And this is simple, so we call it simple interest. In compound interest, however, the amount started at £300, but each successive year it increased to £315 and then £330.75. The amount of interest you receive builds upon itself, which is another way of saying compounding. Let's take a closer look at the compound interest calculation. To get from £6,000 to £6,300, we added on 5%. You'll know from my previous videos that to increase a number by 5%, you multiply it by 1.05. And then to get the £6,615 from the £6,300, you would also increase by 5%, so multiply by 1.05. And then the same from year 2 to year 3. So we could actually write this calculation in a different way. We could simply multiply the initial amount by 1.05 3 times. So if you did 6,000 multiplied by 1.05 a second and third time, you would get £6,945.75. We could actually speed up this calculation even more. If you multiply the same number 3 times, you could write that number to the power 3. So this calculation could actually be 6,000 multiplied by 1.05 to the power 3. Let's take a closer look at this calculation. 6,000 was the initial amount of money we started with. 1.05 was the multiplier for a 5% increase, which was linked to the rate of interest. And the number 3 here was the number of years. You can see that all of these numbers come from the information we were given above. Let's see if we can now use this to quickly work out a compound interest calculation. In this example, we're going to do £750 invested for 4 years in an account paying 2% compound interest, and we need to work out how much the investment is worth at the end of the 4 years. So for this one, the initial amount of money is £750. The rate of interest is 2% compound interest, so we will multiply this by 1.02, but it's for 4 years, so we do it to the power 4. If you type this in your calculator, you'll end up with this. Now, since we're dealing with money here, we must round it off to 2 decimal places. You can't have 82.412 pence. So we'd say the answer for this one is £811.82. Here are 2 more similar calculations for you to try. Pause the video and give them a go. For this first one, you start with £1,250. The rate of interest is 3%, so you multiply this by 1.03. And this is for 5 years, so you do this to the power 5. Your calculator will look something like this, so we will round this off to £1,449.09. For the second example, you start with £430. The rate of interest is 5%, so we'll multiply this by 1.05. And it's for 7 years, so this to the power 7. Your calculator will look like this, so we end up with £605.05. We've now looked at how you calculate with simple and compound interest, but exam questions are often much more complicated than these ones we've seen so far. Let's take a look at how this topic can be assessed in exams. For this example, it says £3,400 is invested for 3 years in an account paying 5.5% compound interest. We are asked to work out how much interest is paid into the account after 3 years. So we can start in the same way as we did before. £3,400 is invested, so we'll start with that amount. It's 5.5% compound interest, so we'll use the compound interest calculation, which is multiplying by 1.055, and it's for 3 years, so we do this to the power 3. This will give us this number here. Now that number represents how much money will be in the account or the value of the investment after 3 years. But the question doesn't ask for that. It says how much interest is paid into the account. So since we started with £3,400 and we've ended with £3,992.42, the interest is the difference between these two values. So to answer this question, we would do £3,992.42 subtract £3,400, and that will give you £592.42. What you need to understand from this question is there are different answers depending on what you're asked to find in the question. If you're asked to find the value of the investment, it would have been £3,992.42. If you're asked to find the amount of interest, it's £592.42. In this next example, we're told that Frank wants to invest £2,000 in a bank for 4 years, and he sees two offers. We have offer 1 and offer 2. We need to work out which offer gives the greater investment. Let's take a look at offer 1 first. Frank is going to invest £2,000, so we'll start with that. And it's 3% compound interest, so we'll multiply this by 1.03, and it's for 4 years, so to the power 4. So we end up with £2,251.02. Now for offer 2, which is slightly more complicated. In offer 2 it is compound interest, but year 1 is 6% and all other years are 2%. So for the first year we have £2,000, but we have an interest rate of 6%, so we need to multiply by 1.06. But we're not going to do this to the power 4, even though it's 4 years, because the rate of interest of 6% is only there for year 1. For all of the other years it's 2%. So we would then multiply by 1.02 for each of the remaining years. If we've used 6% for the first year and it's 2% for the remaining years, there are 3 more years. So we do 1.02 to the power 3. You can now see from this calculation that we have 6% for year 1 and 2% for years 2, 3 and 4. If you do this on a calculator, you'll get 2249.76. The question wanted to know which one gives a greater investment, and the one with a bigger number is this one here. So we would say that offer 1 gives the greater investment. In this next example, we are told that Penny invests £400 at 3.5% compound interest. She withdraws the money when she has made at least £100 of interest. We're asked how many years will Penny need to wait. So we can start with the usual compound interest calculation. We have £400, and the rate of interest is 3.5%, so we multiply by 1.035. But for this question, we don't know how many years it is. In fact, that's what we need to work out. We are told, though, that Penny wants to make at least £100 of interest. So if she's going to start with £400 and she wants £100 of interest, we could add 400 and 100 to get 500. This means she wants to end up with at least £500 in total. So we're going to need to try different years and see if the investment is worth more than £500. So what if we did this just for 1 year? So it was multiplied by 1.035 to the power 1, or just 1.035. Well, this will give you £414, which is clearly not above 500. So what if we do the calculation again, but multiply by 1.03 to the power 2 for 2 years? Well, this gives £428.49, so we're still quite far away from 500. So we'll keep going. Now you can continue to increase the number of years by 1 each time, so do 3 years, 4 years, and so on, but since we're quite far from our target of 500, I'm going to skip a few and try 5. So 400 times 1.035 to the power 5 for 5 years, which gives £475.07. So even 5 years is not long enough. So let's try 6 years, and to the power 6 will give us this number, and that's very close now, so we'll try 7 years. So multiplying by 1.035 to the power 7 gives you this number. And finally, we have a number over £500, which means Penny has made at least that £100 of interest. So the answer to this question is Penny will need to wait for 7 years. For a question like this, it's particularly important to check the year before the year of the answer, so the 6-year one here. If we're going to show that 7 years was the first year that Penny received enough interest, we need to show that the year before this was not enough. For example, let's imagine that rather than skipping to 5 years and then trying 6 and 7, we actually skipped all the way up to 8 years. Well, if we skipped along to 8 years, we would have ended up with this number, and we may have thought that this was the answer to the question because it's above £500, but it's not the first value above £500. If we checked the one before, we would have found that that's also above £500. So it's particularly important that you check to find a number either side of the answer, one below 500 and one above 500. In this next example, we're told that Rich invests some money at 4% compound interest. After how many years will Rich's investment double in value? Now this question seems quite strange at first, because we haven't been told the number of years, that's what we need to work out, but we also haven't been told the amount of money that Rich invests. The only thing we've been told is the rate of interest. Questions like this often throw students, But there is a simple way of approaching this question. You can simply make up an amount of money that Rich invests. I would advise choosing a nice, simple, straightforward amount of money, like say £100. And since the question wants to know how long it will take for the investment to double in value, we just want to know how long it will take for this to become £200, since double 100 is 200. The rate of interest is 4%, so we'll multiply this by 1.04, and then we're just going to change the number of years, just like in the previous example with Penny, until we receive the right amount of money. So if you do it for 1 year, you'll end up with £104. That's clearly not anywhere near double. So let's try 2 years, so £100 multiplied by 1.04 to the power 2. And that comes out at £108.16. Now that's clearly still quite far away from £200, so we're going to need to increase the number of years much more. Now you might want to give this one a try on your calculator to see if you can find the correct number. If you did £100 multiplied by 1.04 to the power 17, you'd end up with £194.79, which is just a little bit below £200. And then if you did £100 multiplied by 1.04 to the power 18, you'll end up with £202.58. Since the amount for 17 years was below £200 and for 18 years is above £200, we can be sure that 18 years is the first value above £200. So the answer to this question is 18 years. Now for this question we made up an amount of money for Rich. We chose £100 and we wanted to see when it doubled to £200. Most students find this the easiest method for this question, but you can actually do this question without making up the amount of money at all. If we take a closer look at 1.04 to the power 17 and 18, if you do these separately on your calculator, you'll find that they give these values here. So when we multiply by 1.04 to the power 17, we're multiplying by 1.9479 and so on. So we're multiplying by a number slightly smaller than 2, which means we're not quite doubling the amount of money. When we multiply by 1.04 to the power 18, we're actually multiplying by 2.0258 and so on. So a number slightly bigger than 2, which means we're doing slightly more than doubling. So even without the amount of money, you can still see that the answer must be 18 years. But if it's easier for you, then make up an amount of money for this sort of question. And it won't matter which amount of money you choose, as long as you show you're working out clearly. In this next question, we're told that Ruby invests some money at 6.8% compound interest for 3 years. After 4 years, Ruby's investment is worth £718.73, and we need to work out how much money Ruby originally invested. Normally, we start a compound interest question with the amount of money originally invested, but in this question, that's what we're trying to work out. So we'll give that a value. Let's say it's the value x. We are told the rate of interest though, and for how many years. So when doing the calculation, we would start with the original investment, which we've actually said is going to be x. We have a 6.8% compound interest, so we'd multiply this by 1.068, and since it's 3 years, we do this to the power 3. So this is how we would normally do a compound interest calculation. But this question's interesting because we're told the amount of money that the investment will be worth after 4 years. We know the answer to this calculation, it must be £718.73. So we can write that this is equal to £718.73. Some of you may now recognise this as a reverse percentage calculation, just like my last video. If you're not familiar with that, you may want to go and watch it. There's also a link to that one in this video's description. Just like in that video, to solve this, we'll divide both sides by what we're multiplying x by, and in this case it's 1.068 to the power 3. So we'll divide both sides by 1.068 to the power 3. On the left hand side that will give us x equals, and on the right hand side we have £718.73 divided by 1.068 to the power 3. If you do this on your calculator, you'll end up with £590. For the next question, we're told that Bill invests £670 in a bank for 3 years. The bank pays compound interest, and after 3 years, Bill's investment is worth £825.39. And we need to work out the rate of interest to 1 decimal place. So for this question, we're told the initial amount, that's £670. Normally, we would now multiply by a multiplier linked to the rate of interest, but in this question, we don't know the rate of interest. In fact, that's what we're asked to work out. So let's say the multiplier for this rate of interest is the letter x. So we would multiply by x, and we would raise this to the power of the number of years, which we are told that's 3 years, so x to the power 3. We are also told the value of the investment after these 3 years. It's £825.39. So this calculation must equal that number. So we have another equation to solve here. To solve this, I would start by dividing both sides by 670. On the left hand side, the 670 will therefore cancel, so we've just got x to the power 3. On the right hand side, we'll need to do 825.39 divided by 670, which will give you this number here. Then, since we have x to the power 3 equals this number, we will have to cube root both sides. I'll show you how we do this on a calculator. So if you did this on the calculator, you'll probably have this number on the screen. Then we're going to need to do cube root. You can see the square root function here, but above it, in blue, you'll see this here, which allows us to do any root. So I'll press Shift first, and then the square root button, and you can see I have this little box up here. If I type a 3 in this box, I will do the cube root. Then I'll just press answer since I had the number on the screen before, and then see what this equals. And it gives us this number here. So x will be equal to 1.072000036. Now the question wants us to find the rate of interest to one decimal place. We need to remember that this number we found is the multiplier, so it's not the rate of interest itself. 1.07, for example, represents a 7% rate of interest. And then for the same reasoning, 1.072 will be 7.2% rate of interest. Since there are zeros after this, we can be sure that the answer to this question is 7.2%. So far in this video, we've looked at simple interest and compound interest. Compound interest is actually a specific example of another topic called repeated percentage change. Repeated percentage change does come up in exams, so let's have a look at two of these, and you'll see it's very similar to the calculation for compound interest. In this question, we're told that a YouTube channel has 185,000 subscribers. The creator estimates that the number of subscribers will continue to increase by 25% each year. Use this estimate to work out the number of subscribers that the channel will have in 4 years' time. So in this question, we start with 185,000 subscribers. This is sort of like the initial investment in the compound interest calculation. The creator estimates that this will increase by 25% each year, so that's a bit like the rate of interest. So we would multiply this by 1.25 to increase it by 25%. This will then happen each year for the next 4 years, so we would do this to the power 4. If you do this on a calculator, you'll end up with this number here. Now, since this number represents the number of subscribers, it must be an integer. You can't have a decimal amount of people. So we will round this to the nearest whole number, which is 451,660. So even though this question wasn't about money or investments, its calculation is still the same as compound interest. Let's have a look at another example, this time with a percentage decrease. The value of a brand new car is £40,000. The value of the car decreases at a rate of 15% per year. Work out the value of the car when it is 3 years old. So this time the initial amount is £40,000. The car is worth £40,000. The value of the car is going to decrease though at a rate of 15% per year. To decrease a number by 15%, you multiply it by 0.85. But we're going to need to do this each year for 3 years in a row. So we do this to the power 3. If you do this on your calculator, you'll get £24,565, which would be the answer to this question. Thank you for watching this video, I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not go and try the exam questions that I've written that are in this video's description.